Finding the sum of a finite geometric sequence. Let's start with recalling the nth term of a geometric sequence. So the an is equals to a1 times r, which is the common ratio raised to n minus 1 power. This one doesn't have to be a 1, so if this is a 5, then this is a n minus 5. So for the nth term, when n is equals to 1, we have a1, right? Because when n is equals to 1, 1 minus 1 is 0. Common ratio raised to the 0 power is equals to 1. That's why you don't see an r in here. When n is equals to 2, a1 times r raised to the first power. When a is equals to 3, a1 times r to the 3 minus 1 power. When a is equals to 4, a1 times r raised to the 4 minus 1 power. So that's why when n is equals to 4, the power is always 1 less than the n. When n is equals to 5, the power is 1 less than the n. So in general, the power is always 1 less than n. So this is a geometric sequence. I want to find the sum of nth term. So we have a1 all the way to the nth term, and then we have n terms, right? So tell me the sum of n terms. So that means you add them all up. What is the sum equals to? So the sum of n term, that is s subscript n, which is the sum. So this is a summation symbol. This is a sigma. This is a sigma. I goes from 1 to n, and then this is a a1 times r raised to the I minus 1. So when I is equals to 1, this is a 1 minus 1. When I is equals to 2, this is a 2 minus 1. When I is equals to 10, this is a 10 minus 1. And then we go all the way to n. So n is a countable value. That's why this is called a finite geometric sequence. So what is the sum equal to? The sum is equal to the first term times 1 minus r raised to the nth power divided by 1 minus r. I have 4 examples, and then the graphing calculator you screenshots you see here is a smarter way to convert a decimal to a fraction. So let's start with the first problem. We have n goes from 1 to 8, and then in the next 2 problems, I want to explain what happened when n starts at 0. Alright, so let's do it one by one. When n is equals to 1, what do we get? When n is equals to 1, we have a 0 power, so we have a 5 only. And then when n is equals to 2, we have negative 5 over 2. 2 minus 1 is 1. So this is n equals to 1, n equals to 2. The power is always 1 less than the n. When n is equals to 3, we have a 5, negative 5 over 2. 1 less than that is 2. And then we can go all the way to the 8th term, right? So all the way to the 8th term when n is equals to, I can do this when n is equals to 7, 5, negative 5 over 2, 7 minus 1 is 6, and then 5. N equals to 8. This is a negative 5 over 2. 1 less than that is 7. So we have go from 1 to n, and the total is n equals to 8 terms. N equals to 8 terms. And then what is the common ratio? The common ratio is r equals to negative 5 over 2, and then the first term is equals to 5. And then what is the sum? We have s, and then we have 8 terms. So this is a 5, and then 1 minus the common ratio, 5 over 2. Here is a problem. The problem is we have an 8th power, and then the bottom is 1 minus the common ratio. So the problem is you have an 8th power. So after taking the 8th power, both the denominators and numerators, they are pretty big. Plus, you have to do the common denominator. That is pretty annoying. So what I am going to do is I am going to take care of the denominator. So the denominator is 5, right? The denominator, so this is a 1 plus 5 over 2, which is a 7 over 2. And then 5 divided by that, 5 divided by 7 over 2. But I wrote 7 over 5. So 7 over 2. That is equals to 10 over 7. So what I am going to do first is I am going to type this to my calculator. Do you see this? I type this to my calculator. So 5 and then the denominator together, we have a 10 over 7. And then we multiply the numerator. 1 minus negative 5 over 2 raised to the 8th power. Of course, you are going to get a decimals. And then when you are doing works online, they do not accept decimals. They want you to report the exact answer, which is in fraction. Now, but I don't want to waste any time to do the common denominator. What do we do then? So here is what we are going to do. You have the result, and then in your graphing calculator, you press the math key. So there is a math key. Just take out your TI83, TI84, take a look at the keys. There is a math key. Once you hit the math key, select the first one. Here, select the first one, FRAC, fraction, and then click enter, and then you will see this. They will try to convert your answer to fraction, and then you got this. So if you know this technique, that will save you a lot of time from doing common denominator. Of course, save you a lot of time from doing a common denominator, but accidentally making a mistake. All right. So overall, what is that equal to? That is equals to negative 278. I'm going to copy that straight from my calculators. 278,835. 278,835 divided by 128, and then this is the sum. And that is the answer to the first question. All right, so let's do the next one. The next one is in red. So we have a summation. N goes from 0 to 40, and then we have a 5 and then a 3 over 5n. So what happens when n starts at 0? It's okay. I can just take it out. So when n is equals to 0, we have a 5, right? And then when n is equals to 1, we have a 5 times 3 over 5, and then to the first. Okay, this one when n is equals to when n is equals to 2, when n is equals to 2, we have 5 3 over 5 to the second power, and then we go all the way to the 40th power. So 5 and then 3 over 5 and then 40th power when n is equals to 40. So how many terms are there? So the total is 40 plus the 0, n equals to 0. From 1 to 40, there are 40 terms. And then you have an n equals to 0, so the total is 41 terms. And then what is the common ratio? The common ratio is 3 over 5, and then the first term is equals to, what is the first term? The first term is right over here. The first term is, I am going to take that, bring that over, 5 times 3 over 5, that is equals to 3. All right, then what about the sum? Here is the sum. So that's why I pick a problem where n starts at 0. As the sum of 41 terms, I put the 5 right here. And then I apply the formula. So I am going to treat this as one piece. So I will just ignore the 5 and then apply the formula to this piece. And then the 5, I will just leave it outside. 5 plus 81, which is 3. And then 1 minus the common ratio, 3 over 5. And then raised to what power? 3 over 5 raised to what? Raised to the 41 or 40. Raised to the, take a look, nth power. So this is supposed to be a 40. Why? How come this is not a 41? Because we already take the 5 out. It is no longer 41. And then 1 minus 3 over 5. And then as always, this one is going to be 5 and then plus. So this one 1 minus 3 over 5 is a 2 over 5. 3 divided by, I should do it like that, 3 divided by 2 over 5. You flip the 5 up, that is a 15 over 2. So you have a 15 over 2, and then multiply 1 minus the common ratio to the 40th power. I didn't have the screenshot, but use the technique I taught above there, and then you will get 12.500. That is the sum. To the second summation. And then how about the last one? The last one in blue, you have 0 to 50, and then 10 times 2 over 3, n minus 1. Let's do that. So we have summation, n equals to 0 to 50, and then you have 10, 2 over 3, and then raised to n minus 1 power. This one, if you don't want to include the 0, take the 0 out. When n is equals to 0, that is just a what? That is just a 10. That is just a 10. And then plus n equals to 1, you have a 10 and then 2 over 3 to the 0 power, which is just equals to 10. And then when n is equals to 2, you have 10, and then 2 over 3, 2 minus 1. And then when n is equals to 3, 2 over 3 to the second power, n equals to 3. And then n equals to 4, 2 over 3 to the third. And then we go all the way to where? We go all the way to the 49th, right? 10, 2 over 3, and then 49 power. This is n equals to 50. 50 minus 1 is 49. And then what is the first term? The first term is right over here. The first term is equals to 10. And then the r is equals to 2 over 3. And then the sum, 51 terms. So we have 51 terms. We have the n equals to 0, and then the rest of the 50. So s of 51, that is equals to, we bring the 10 over, and then we have a1. So a1 is 10, and then we multiply 1 minus 2 over 3 to the 50 power, and then 1 minus 2 over 3. And then using the technique I taught over there, you should be able to get the sum. So here is what I am going to say. I think on the notes, because I prepared the notes already, I think I accidentally put a 15. I accidentally put a 15 in here. So that might affect the sum. So I don't want to just bring the sum over from my notes over to this video in case that is a mistake. So use the technique I taught. You go find out what the sum equals to. So what I am going to do first is I'm going to do a 1 minus 2/3, like right over here. So 1 minus 2/3 is equals to 1/3. And then you have 10 divided by 1/3. So this is equals to 30. And then you have a 30 times that. And then you use the calculator, convert that to a fraction, and then you add 10 to it at the end. All right, so that one, the sum, I will just leave that to you. And this is also the end of this video. If you like the way I explain this type of problem, give this video a thumbs up. If this is something that you want to see, this is the math class that you are expecting to get every single every single semester or quarter, give my channel a subscribe. Trust me, it is worthwhile coming back to with more content. As always, I will see you all in the next lesson. Signing out.